Hey guys, this is Ivan Ivanitsky from Reactive Network, and today I'm here to present you a workshop for building on ETHSF hackathon. So I should be able to see the comments that you can write on YouTube. So please write some comments so that I will be able to see whether you're watching this. I can just give me a moment to make sure the translation has started successfully. Okay, let me take a look. Yeah, looks like it's working. But I don't see any participants yet. However, I will still present the workshop because it will be recorded and you will be able to watch it later. Okay, so basically, let me share some information about Reactive Network first. So Reactive Network is a solution for cross-chain interoperability, automation, and modularity. What we do is Reactive Smart Contracts. They allow to react to on-chain events with on-chain actions. So you can see the basic workflow on the screen. The origin smart contract may be, for instance, on the Ethereum network, the destination smart contract on Polygon network, or also on the Ethereum network, or BNB, or any other network that we support. And there is a reactive smart contract in the middle that catches events on the origin smart contract and then sends callback to destination smart contract, thus enabling automations, cross-chain interoperability, and modularity, where you can build on top of existing solutions by just listening to their events. So first of all, let me, I will, how do you, yeah, sorry. Yeah, I believe the part of it is not visible right now, but anyway, you can find it in our cheat sheet as well. So that's the information on our tracks. So there is a main track where we ask the hackathon participants to focus on creativity, business impact, and implementation complexity. So there are 3 prizes, 4K USD paid in ETH for the first place, 2K for the second place, and 1K for the third place. And then there's a side track where you can build even the simplest solutions. And if they incorporate reactive in even the simplest form that still makes sense, you'll be eligible for a prize out of 3K prize pool that will be distributed amongst participants based on the judging. All right. So I would also like to share a bit more complex examples. So I shared the basic workflow on the first slide, but also there is a good example of reactive smart contracts usage, which is Uniswap stop order. And with Uniswap stop order, it happens as follows. So there is a Uniswap pool which has swaps and sync events. And sync events, they have information about the liquidity in the pools, which allows us to calculate the exchange rate and thus implement a stop order on top of that. So whenever a price reaches a predefined amount, we swap tokens on the Uniswap pool the same way we do it on a centralized exchange. So in that case, a Reactive Smart Contract is monitoring those sync events and calls callback smart contract whenever there is the price reaches the threshold, and so executes the swap. So there are a few tweaks. I will also share a doc where you will find all the links to the information, but generally there are several differences between reactive smart contracts and usual solidity smart contracts. I say a few because basically reactive smart contracts are written in simple solidity, and the differences are few. So one of the important differences, I will just point it out right now with this scheme, and after that I will point you to the docs because we have it described in detail. But the difference is that on reactive network, smart contracts exist in two instances, basically, a network instance and React VM instance. So network instance is the one that you can call directly, and React VM instance is the one that actually reacts to events. And they have a separate state, and I won't dive into those details for now, but I will provide the links to the docs where you can read about it. It might sound a bit confusing initially, but generally you will be just working with the React VM instance mainly, and with its state, and it will react to on-chain events and send callbacks. Yeah, so this is the last slide. After that, I will jump straight to the code. Please scan this QR code here to join our chat. And in our chat, you will find the link to all the useful information. As a matter of fact, let me share my screen and show you what I mean by that. Yeah, so this is our chat, Reactive Network. It's called Reactive Devs. So by using this Telegram handle, you will get to our chat, and you will see announcements here and this doc right here. And I will walk you through this doc in a moment. So let me share another window now. This one. So here you will find a detailed description of all the bounties and judging criteria. So it might look like we have a lot of judging criteria, but as a matter of fact, it all boils down to the fact that you should implement some reactivity and make it work, and provide the transaction hashes for us to be able to validate that you actually used reactive smart contracts and reactivity in your project, right? And what I wanted to show you is this list here. I tried to make it as useful for you as possible. It has all the links, so feel free to ask any technical and organizational questions here in the chat. We will answer it. Also, you can read about the basic stuff here. You will find schemes, explanations, just to understand what reactive network is. Then you can use this repository as a boilerplate project. We'll take a look at this example a bit later today on this workshop. And then also here you can take a look at the winners of our previous hackathon. So it's a non-locking flash loan, which allows liquidity providers to provide liquidity by just approving tokens, not by locking them in a pool. Dynamic royalty, which manages royalty payments using reactive smart contracts. Also Flash Profit Extractor, which allows to extract additional profits. Also, you can find some other stuff here, such as, for instance, Reactive Bridge, which is basically a bridge built on Reactive Network. So this is a bridge between two EVM networks, but Reactive is using for its cross-chain functionality. And yeah. So you can take a look at those code examples, as well as presentations and docs. These are pretty good examples of how Reactive Network can be used. So the network enforcement information here. Then also I would suggest that you read those 4 places in the docs. Basically, it's about the moments that might be complicated or confusing, the differences between Solidity smart contracts and reactive smart contracts, which I have said are not very big difference. So, yeah, and now let me proceed with the code examples. Okay. So this is a basic demo that you can find in our repository using the link that I shared before. So there is a bunch of examples here. There is approval magic, which allows simplifying swap use case, for instance, where you approve, you just do one approve, and then the swap happens automatically using Reactive Network. You might dive into that. But basically, I will like to just demonstrate the basic functionality on the basic example. And also, I will take a look with you at the stop order that I mentioned earlier. Also, please feel free. I see that we have a bit more viewers now, so please feel free to ask any questions. I'm trying to sometimes take a look whether you written any comments here on YouTube. I mean, not comments, but messages in the chat, and I will be answering them. Okay, so let me proceed with the code. So first of all, let's take a look at the code, right? So we will start with the basic example. It does not do a lot. It just demonstrates what reactive smart contracts do on a very basic level, just the concept, right? So as you could have seen on the scheme earlier, there's 3 smart contracts here. So a what we call an origin smart contract, which we are monitoring. Then a reactive smart contract, which does the monitoring and sends the callback, and the callback smart contract with which we interact. In practice, origin smart contract and callback smart contract might be one smart contract. They might be on one chain, or they might be on different chains. So in that particular example, they're on one chain, Sepolia testnet, and they're 2 different smart contracts. So this is a super basic example. So all it does here, it just this is the wrong contract. This is the right one. So it has this receive function payable, right? So whenever this smart contract receives Ether, it emits received event, and it sends back the funds, right? Then there's reactive smart contract, in which we will dive a bit later, and there's a callback smart contract, which basically has only one function, callback, to demonstrate the capabilities of reactive smart contracts. So this callback function is called by a reactive smart contract whenever an event happens on the first smart contract that I have just shown you. So this callback function just emits an event for us to see that everything worked. So and now let me share the reactive smart contract with you. So it has a bunch of stuff here. Basically, a lot of it is a boilerplate stuff, and you can use this Uniswap stop order here as a boilerplate project, right? But yeah, so first of all, it is inherited from abstract reactive, the same way as this smart contract here is inherited from abstract callback, and this origin smart contract can be arbitrary. So I won't dive in those details right now. You can take a look at those contracts here. Basically, they allow paying for the callbacks, right? So whenever you create a callback smart contract, make sure to inherit it from abstract callback smart contract from our lib. It also is here in the demos repository. And whenever you create a Reactive Smart Contract, you inherit it from Reactive, right? So, okay, so this is the basic event that contains all the information about the event that happened on the origin smart contract. This is what we will be using later, so poly, chain ID, and gas limit. This is constructor. And in constructor, basically what happens is we subscribe to the events on the origin smart contract. So here you can find the chain on which we subscribe. In that case, that's Sepolia, contract address, topic 0 of the event to which we subscribe, and those 3 parameters, we don't need them for now. Then the main magic happens here in the React function, right? The React function is being called automatically whenever an event of interest happens, an event to which we subscribed earlier, right? And it basically executes the logic of how you want to react. So you describe most of the logic here in this React function. So in that particular case, it just checks that the value of the transfer from the to the origin smart contract, which was emitted in this event here. Let me show you again, right? In this received event, right? So this is basically the value of the transaction. It makes sure that it's more than 0.01 so that you can check that it actually works. You can send less and it won't send a callback. You can send more and it will send a callback. And it constructs the callback here, right? And emits the callback. So this is a keyword, emit callback, a keyword in Reactive Network. So for usual Solidity smart contracts, that would be just an event, right? But for Reactive smart contracts, this event actually initiates the callback to the destination smart contract, right? In that case, we're calling callback function here in this callback contract here, right? Okay, and that's it, more or less. We don't need to discuss this stuff for now. So let me dive into practical demonstration. First of all, let me see the chat. No questions in the chat yet. And then let me proceed to practical demonstration. Right, so we have a README here. You can just follow these steps and see how it works, right? So I've already executed the first 2 steps for you to skip the waiting, but also because we need to input the addresses of the contracts to environment variables, and I didn't want to show that on screen. So yeah, I did that beforehand. So you can read all the explanations here. So we try to make the docs as clear as possible. Yeah, so the first step is to deploy the basic demo L1 contract, which in our case is origin smart contract. So we run this query, and after that we save the deployed to, right, as origin address in our environment variables, right? So I ran this query here. You can, yeah, you can see it here. Forge create a legacy. This is RPC URL. Make sure, by the way, that you enter all those values here. You can find them using the links, and some of them are your private keys, right? So make sure to prepare all that stuff before you run the actual demo. Basically, just go through the README and it will explain everything. All right, so destination RPC here, private key here, the smart contract file. Then we deploy it as a usual Solidity smart contract, because it is a usual Solidity smart contract on Sepolia network. And we take this deployed to here and save it as origin address here. Yeah, if you're on Windows, make sure to restart the terminal, because it only sees the environment variables that were there at the start of the terminal, right? Then I try to deploy the destination smart contract, ran into some issues with Sepolia, but I just tried again and it worked. So here is this one here. This is the step 2, where we deploy the callback smart contract. Basically the same query, just with a different smart contract, and make sure to give it some value, because a callback smart contract will need to have Ether on it. I mean, the gas token, or whatever it is, Ether on Ethereum, Sepolia, Ether on Sepolia, and so on, right? Because the callbacks will be paid by Reactive Network, but then Reactive Network will charge your smart contract for the callback, right? And that's why it has to have gas here. So basically, if you take a look here in Reactive Lib, right, you will see, yeah, probably not here. Yeah, correct. So let's take a look at this callback smart contract here. As I have said earlier, our callback smart contract, it's inherited from this one, right? And this one is abstract payer, right? And it has a bunch of functions here. I won't go through this right now. We have a link in the doc that I shared earlier, and in the docs, just take a look at economics page at our docs, and this is explained, like how the callbacks are paid, and yeah, I won't go into these details later, but all we need for now is just to provide it with some value. I didn't do it because I just needed to run one callback, and one callback can be done without this thing. Then we are at the third step. So as you can see, I've already got this deployed to address. And as you can't see, I've saved it in my environment variables as an origin address. I've restarted my Visual Studio to restart the terminal. And now we can run this query here. I hope I didn't make any mistake. So first of all, let's go back to the folder of interest. Yeah, and what we're doing here is we're deploying the Reactive Smart Contract, which is deployed basically the same way as a usual Solidity Smart Contract. So it's forge create, legacy, RPC, URL, private key, the contract, also the value in Ether, right? Also the constructor arguments for our Reactive Smart Contract, which is a system contract address. You can find information about it right here. Then the origin address of the first contract that we deployed, the callback address of the second contract that we deployed, and topic 0 of the our received event, right? Let's go. So basically what we're doing here is we are deploying a Reactive Smart Contract, right? You can see constructor arguments here, a service smart contract, origin smart contract, topic 0, and destination smart contract, right? So we deploying the Reactive Smart Contract to monitor our origin smart contract and to send callbacks to the destination smart contract whenever the event of interest happens and conditions are met. Right. So now we can go back to the README and we can actually execute the fourth step. However, before that, let me share the screen a bit differently so that we will be able to see the Sepolia scan as well. Just give me a minute. Okay. So let's go. So yeah, this is the doc I've shared earlier. So to read about events and callbacks, you can go here, about the subscriptions here, about the difference between React VM and Reactive Network here. And this is what I mentioned during the code demo, the economy. Here you can read about how the callbacks are paid and so on. I won't dive into this now, but this is a pretty well-written doc, so you can refer to that. Now, yeah, let's go to Sepolia. Sepolia scan. And let's input our values here. So yeah, so this is our origin smart contract, right? Yeah, I want contract. Yeah, fortunately I am human, it says, right? Yeah, so you can see just a freshly created contract here. Then let's go to our destination smart contract, this one right here. And it also has nothing here. And also we can go to Reactive Network here, and we can go to Reactive Scan. Only, yeah, let's do it a different way. So this is the mainnet scan. We are currently on testnet. So we go to the testnet scan. So this is mainnet, this is testnet, right? And yeah, so this is my address here. And let's see the same address on Reactive Network. Yeah, so you can see basically that it has just one transaction here, which is a reactive contract deployment, right? So we can actually go to this. So as you can see, React Scan shows a bunch of cool stuff here. So no callbacks yet. And this, I believe, is our smart contract, is it? Yeah, it's deployed to CC7. So yeah, this is our reactive smart contract. And now we will proceed to the actual reactivity, right? Just let's run the fourth step. So yeah, we've deployed the reactive smart contract, and now we can test that it actually works. So let me remind you that our stuff will look like that. We will just send some ether to our origin address, right? And it says destination RPC here, destination private key here. It's because in our case, it's all on Sepolia, both destination and origin, right? So we will send it here. It will be received. A received event will be emitted, caught by a reactive smart contract, and then a callback will be sent here, and the callback function will be called, and this event will be emitted. Okay. So this is a transaction on Sepolia. Okay, so now we can go here to our origin. Yeah, I believe it is our origin, isn't it? is it Destiny? No, I think it's the origin smart contract. Yeah, correct. 1DA. It shows here. Yeah, let's refresh the page once again. Okay, yeah, it's correct. So yeah, you can see a transaction received here. You can see a received event emitted here. Now here, in a few moments, something will happen. Yeah, but for now, let's see the reactivity transaction here. So this is a contract deployment transaction, and this is actually a reaction, right? So it interacted with this thing here, and it says that this reactive transaction produced a callback transaction to Cipolle in this one, right? So we can see the origin transaction as well. We can see all the payloads here, which is pretty cool. And let's take a look at the destination transaction, right? Yeah, first of all, let's take a look here. Let's refresh the page. I hope the ETHScan has already caught it. Yeah, so since the callback is sent from our proxy smart contract, it won't show a transaction here in transactions, but it will show it in internal transactions if you go to advanced mode, right? And it will show the events. So as you can see, I didn't lie, and callback received event was emitted. So this transaction here, so this execution was reverted, and that's good because we only need one callback. But this is actually our callback. It happened 2 minutes ago, which is pretty fast because I believe it was 2 minutes ago when I sent the funds, right? And you can see the callback received event here. And this is basically everything I wanted to show you live, because we have some more complicated demos, and they also make more sense. But yeah, this is the basic workflow, and I hope now it's clear how Reactive Network works and how to deploy a Reactive Smart Contract, how to use it, how to deploy a callback smart contract. So yeah, this is basically what you will be doing, just with more complicated smart contracts, with more complicated callbacks. You can also like send the callbacks to the reactive smart contract itself. You can then make sure using reactive smart contract that the callback was received. You can, for instance, monitor this event on a callback smart contract. You can do a bunch of cool stuff. But anyway, that's the basic thing. Let me take a look at the chat. So no questions yet. Please feel free to ask any questions. I will show one more thing and call it a day. So this is a super basic example. And I don't even recommend using it as a boilerplate because it's too simple. But what you can take a look at is this Uniswap stop order example. I won't be running it live, but I'll walk you through the contracts, right? So there is a token, right? There is a callback smart contract here, which executes the stop order. And also under the hood, there is usual Uniswap version 2 pairs. And also there is a stop order reactive smart contract, which actually catches those sync events. As a matter of fact, let me show the scheme again. I won't go to the scheme again. Just let's proceed with this thing here. Right, so it's a bit more complicated and a bit more meaningful reactive smart contract. It catches sync events on a Uniswap pair and calls the callback smart contract to execute the trade whenever the price of interest is reached. So when we deploy this reactive smart contract, we set the price at which we want to sell or buy, right, at a Uniswap pool swap anyway. And then whenever this price is reached, the actual swap is executed, right? So we have this sync topic 0 here. order stop topic 0 here to stop the reactive smart contract whenever a stop order is executed. Yeah, a bunch of stuff here. So in constructor, basically, we just set up the values and we subscribe to the two of those events. One of them sync event on a Uniswap pair, and one of them is stop orders stop on our callback smart contract, right? React function is called whenever any of those two events is caught. So in case it's a sync event, then this branch is executed where we construct a callback, which is called stop. So you can take a look at this callback contract here. It has a stop function, which we will be calling, right? And it triggers this stop function here if the sync event data is below the threshold, right? Which basically indicates that the price is, yeah, let me see. Yeah, correct. That indicates that the price has reached its limit. And then it executes the callbacks by calling this stop order, right? So this is the calculation of the price, whether it has reached the threshold. And then let's take a look at the stop, the callback smart contract, its stop function. So basically what it does, it has these two tokens here. It checks, it gets the reserves of this pair to make sure that the price is still correct, because obviously there might be a delay before the smart contract, the reactive smart contract catches the event and then executes this trade. It's a pretty small delay, but as you know, a price might change significantly. So yeah, we need this check here. So we require that this stuff is below threshold. Then we set the which token we sell and which token we buy. It's specified by this is token input parameter, right? Then we have this ERC20 interface, right? We make sure that we have allowance for this trade, right? So the user has to approve funds for the callback smart contract to be spent, like the tokens that he wants to swap, basically, right? So we check this allowance, check the balance, and then we execute transfer from client to the callback address, so to this contract which we're looking at currently. Then we approve the tokens to be swapped, basically, and then we execute the swap on the Uniswap pair, and then we transfer the tokens back to the client, and then we emit a stop event. And this is an interesting part. So as you can see here, it basically takes the tokens, execute the swap, and sends back the new token to the user. And then it sends the stop event so that the reactive smart contract sees this, catches this stop event, right? And then makes sure that it doesn't work anymore. It turns this done variable to true. And here you can see this check done, so that it doesn't execute the trade several times, because it's only set up for one trade. But basically you can improve this contract and make it reusable and or apply it to a different DEX and so on. All right. Yeah, and you have the same README basically here, so you can run all this workflow. It's a bit more complicated than the previous one, but still pretty simple. Just make sure to correctly use all the variables, and you're good to go. Okay. So as I have said earlier, please feel free to join our chat. I don't see any questions in the chat. I will stay here for 1 more minute in case you guys have any questions. And after that, we will end this workshop. Thank you very much for attending it. And I'm looking forward to seeing your applications at ETHSF hackathon. Please feel free to reach out to us in the chat. Please see the doc that I shared earlier and the link to which you can find in announcements of the chat that you can find on screen. And yep, and that's it. So thank you very much. Good luck and have fun.